Welcome back. TESS discovers a planet the size of Mars but with the makeup of Mercury. The boiling new world, which zips around its star at ultra-close range, is among the lightest exoplanets found to date. Ultra-short period planets are small compact worlds that whip around their stars at close range, completing an orbit in less than 24 hours. How these planets came to be in such extreme configurations is one of the continuing mysteries of exoplanetary science. Now, astronomers have discovered an ultra-short period planet that is also super light. The planet is named GJ367b and it orbits its star in just 8 hours. The planet is about the size of Mars and half as massive as the Earth, making it one of the lightest planets discovered to date. Orbiting a nearby star that is 31 light years from our own Sun, GJ367b is close enough that researchers could pin down properties of the planet that were not possible with previously detected USPs. For instance, the team determined that GJ376b is a rocky planet and likely contains a solid core of iron and nickel, similar to Mercury's interior. Due to its extreme proximity to its star, the astronomers estimate GJ376b is blasted with 500 times more radiation than what the Earth receives from the Sun. As a result, the planet's dayside boils at up to 1,500 degrees Celsius. Under such extreme temperatures, any substantial atmosphere would have long vaporized away, along with any signs of life, at least as we know it. But there is a chance that the planet has habitable partners. Its star is a red dwarf or M dwarf, a type of star that typically hosts multiple planets. The discovery of GJ367b around such a star points to the possibility for more planets in this system, which could help scientists understand their origins. For this class of star, the habitable zone would be somewhere near a month-long orbit, says team member George Riker, senior research scientist in MIT's Kavli Institute for Astrophysics and Space Research. Since this star is so close by and so bright, we have a good chance of seeing other planets in this system. It's like there is a sign saying, "Look here for extra planets." The team's results appeared today in the journal Science. The study was led by researchers from the Institute of Planetary Research at the German Aerospace Center, in collaboration with an international group of researchers, including MIT co-authors Riker, Roland van der Spek, and Sarah Seger. The new planet was discovered by NASA's Transiting Exoplanet Survey Satellite, TESS, TESS, an MIT-led mission, of which Riker is principal investigator. TESS monitors the sky for changes in brightness of the nearest stars. Scientists look through TESS data for transits or periodic dips in starlight that indicate a planet is crossing and briefly blocking a star's light. For about a month in 2019, TESS recorded a patch of the southern sky that included the star GJ376. Scientists at MIT and elsewhere analyzed the data and detected a transiting object with an ultra-short 8-hour orbit. They ran several tests to make sure the signal was not from a false positive source, such as a foreground or background eclipsing binary star. After confirming the object was indeed an ultra-short period planet, they then observed the planet star more closely using the High Accuracy Radial Velocity Planet Searcher (HAPS), an instrument installed on the European Southern Observatory's telescope in Chile. From these measurements, they determined the planet to be among the lightest planets discovered to date, with a radius that is 72% and a mass that is 55% that of Earth's. Such dimensions indicates that the planet likely has an iron-rich core. The researchers then whittled down various possibilities for the planet's interior composition and found the scenario that best fits the data showed that an iron core likely makes up 86% of the planet's interior, similar to the makeup of Mercury. We are finding a Mars-sized planet that has the composition of Mercury, says Van der Speck, principal research scientist at MIT. It's among the smallest planets detected to date and is spinning around an M-dwarf on a very tight orbit. As scientists continue to study GJ367b and its star, they hope to detect signals of other planets in the system. The properties of these planets, such as their spacing and orbital orientation, could provide clues to how GJ367b and other ultra-short period planets came to be. Understanding how these planets get so close to their host stars is a bit of a detective story, says TESS team member Natalia Guerrero. Why is this planet missing its outer atmosphere? How did it move close in? Was this process peaceful or violent? Hopefully, this system will give us a little more insight. This research was supported in part by NASA. Wow! What an interesting research, and we hope that more insight will be given to us, more scope, more elaborate scope will be given to us in the near future to understand most of these exoplanets properly. Whatever you have to say concerning this, drop your comment in the comment section, and please don't forget to subscribe to this channel. Thank you very much.